Hello dear students, welcome back to the integers class. So in the last class we have completed with the definition of integers. In the definition of integers he has given the definition, that is the numbers which are positive and negative including 0 are called integers. So last class we have studied the definition. Also we have studied the properties of addition. In the properties of addition we have studied first one, that is closure property. Second one, we have studied the commutative property. And third one, you are going to study the associative property. So these three properties you have studied in your last class, that is closure property, commutative property and associative property. Okay, so in the properties, now we are going to study the properties of subtraction. So in the last class you have studied the properties of addition related to closure property, commutative property and associative property. Now you are going to study the properties of subtraction, that is closure property, commutative property and associative property. So see here, what is closure property says, if a and b are two integers, then a minus b is also an integer. So this is the closure property. If a and b are two integers, then a minus b is also an integer. By example we will come to know what do you mean by this. So see here, operation is subtraction, that is a and b are two integer. If you subtract that, if you take the difference, you will get as integer. If a and b are two integer, then a minus b also an integer. This is one. Or one more, if a and b are integer, then a minus b is also an integer. Okay, so see here, I choose a is equals to 2 and b is equals to 3. I choose a is equals to 2 and b is equals to 3. I put in the operation a minus b. In the a minus b operation, if I put a is equals to 2 and b is equals to, and minus sign, operation as it is, b is equals to 3. Again 2 minus 3 which is equals to 1, which is equals to minus sign as it is, because we have to see the greater number sign and we have to keep this sign, that is 2 minus 3 which is equals to minus 1. So this is your closure property. If a and b are two integers, then a minus b is also integer. A minus b is an integer. If we have to verify by taking the example a is equals to 2 and b is equals to 3. A is equals to 2 and b is equals to 3. That is 2 minus of 3 which is equals to minus 1. Next we are having the commutative property. What does our commutative property says? If a and b are two integers, then a minus b, that is, if a and b are two integers, then a minus b which is equals to b minus a. If a and b are two integers, then a minus b is equals to b minus a. I take example, I choose example, that is a is equals to 3 and b is equals to 2. I just verify in this commutative property equation So that is here all of you. A is equals to 3, B is equals to 2. Similarly, operation minus sign as it is, which is equals to again 2 minus of 3. So here 3 minus 2 which is equals to 1 and 2 minus 3 which is equals to minus 1. Why it is minus 1? Because we have to see the greater number and we have to keep the sign. Means 1 is not equals to minus 1. Means we can say that commutative property does not holds good in for subtraction. So commutative property does not holds good for subtraction. Similarly, our last property we are having as associative property. Last property we are having as associative property. So associative property says that is if A, comma B and C are three integers, then we have A minus of B minus C which is equals to A minus B minus of C. So this is your equation for associative property of integers. That is, if A, comma B and C are three integers, then A minus of B minus C which is equals to A minus B minus of C. By solving the example we will come to know, is it associative property holds good for subtraction. So see here I choose A is equals to 2, B is equals to 3 and C is equals to, that is 5. Okay. So A is equals to, I chosen 2, B is equals to 3 and C is equals to 5. Just put in this equation and verify, is it LHS is equals to RHS or LHS is not equals to RHS. So A is 2, that is minus sign, that is operation as it is 3 minus 5 which is equals to, next one 2 minus of 3 minus of 5. Just I put an A is equals to 2, B is equals to 3, C is equals to 5. Similarly, I taken A is equals to 2, B is equals to 3 and C is equals to 5. First we will solve the brackets, that is Bodmas rule. First we will solve, in the previous class we have studied the Bodmas rule. First we will solve the bracket, that is 5 minus 3 which is equals to 2, and by seeing the greater number sign we keep this sign, it is minus 2 which is equals to 2 minus 3 which is equals to minus 1 and minus 5. So 2 minus into minus is plus, 2 plus 2 which is equals to 4, and this is minus 1 and minus 5 which is equals to minus 6. So we are getting this as 2, positive 2, that is minus into minus is plus, and 2 as it is, that is 2 plus 2 which is equals to 4, 4 which is not equals to minus 6. So 4 is not equals to minus 6 means we can conclude that associative property does not holds good for subtraction. So one more two properties you are going to study, that is first one is additive identity. Additive identity. Additive identity. What is additive identity? So that is 0 is the additive identity. 0 is the additive identity. This identity. 0 is the additive identity of integer which means when 0 is added to any integer we get a integer. When 0 is the additive identity of integer, which means when 0 is added to any integer, we get a integer. So means that is I choose a plus 0 or 0 plus a, which is equals to, I get always as a. Means any integer, if added with 0, we always get an integer. Means we can say 0 is the additive identity of integer. Example, by solving the example we'll come to know. So here I choose a is equals to 3, means 3 plus 0, 3 plus 0 or 0 plus 3, which is equals to, I get always as 3. That is a plus 0, which is equals to 0 plus a, which is equals to a. Means if I get 3 plus 0, which is equals to 0 plus 3, which is equals to always 3. So this is the additive identity. Means 0 is the additive identity of integer. Similarly, we study additive inverse. That is your last property of this concept of integer. That is fifth one you are having as additive inverse. Additive inverse. 0 is the additive inverse. For every integer a, for every integer a, there exists a integer minus a. For every integer a, there exists an integer minus a, means which are additive inverse of each other, which means they are additive inverse of each other. Inverse of each other. So see here what does it say? For every integer a, there exists an integer minus a, which means they are additive inverse of each other. That is a plus of minus a, means which means here that is a plus into minus is minus, a minus a, which is equals to 0. Means I choose one example, I choose a is equals to 3. What is additive inverse of 3? That is 3 plus of minus 3, which is equals to 3 plus into minus is, again we are having as minus 3, which is equals to 3 minus 3, which is equals to 0. So this is the additive inverse of each other. Means if you are having 3, means its additive inverse is minus 3, that is 3 plus of minus 3, which is equals to 3 minus 3, which is equals to 0. So all of you have to note down the properties of subtraction. In this video you have learned the properties of subtraction. In the properties of subtraction, first you have learned the closure property, second one you have learned the commutative property, and third one you have learned as associative property, and you have verified with the equation with some examples. And also you have learned additive identity. 0 is the additive identity of the integer, and additive inverse, for every integer a, there exists an integer minus a, which means they are additive inverse of each other. Means a plus of minus a, which is equals to a minus a, which is equals to 0. 3 plus of minus 3, which is equals to 3 minus 3, which is equal to 0. Means all this definition and all these examples you have to note down, and you have to send me on my WhatsApp number.